In this video, we're going to practice with truth tree rules and heuristics for developing truth trees. So here's a set I've written out, and we want to know whether this set is consistent. So we're going to do what we've been getting used to doing. We're just going to stack the members of the set. I'm going to start with 3 lines because there are 3 sentences. I'm going to work toward the middle of the page here. The first one is A arrow B, the second one is B arrow C, and the last one is the negation of A arrow C. Strictly speaking, I can dispatch these sentences in any order, and I will get the correct answer. However, we've learned that it's a good idea to always stack before you branch. So our heuristic is stacks before branches. So we look at each of the 3 sentences. We identify their main logical operators. So the first one is a conditional, the second one is a conditional, and the third one is the negation of a conditional. And identifying those matches them to exactly one rule each. So to decompose sentence number 1, I have to use the rule for the material conditional. And if I try to remember what that looks like, I remember that that branches. Similarly, because the sentence on line 2 also has as its main logical connective an arrow, it's also going to branch because it's going to use exactly the same truth tree rule. The third sentence is the negation of P arrow Q, and we've just learned that that dispatches by stacking P on top of neg Q. So sentence 1 stacks, sentence number 1 branches, sentence number 2 branches, and sentence number 3 stacks. So if I'm going to use the strategy of stacks before branches, I'm going to decompose sentence number 3 first. Okay, let me get rid of some of this clutter. So now I just follow the patterns. So first, to stack, I do lines 4 and 5. I do line 4 and line 5. I do A, neg C, and those came from line 3. And I'm trying to keep my lines as straight as possible. I really should be working on lined paper for truth trees. And I try to make everything as neat as possible so that I minimize the chance of making mistakes. Okay, so now line 3 is dispatched. I can ignore it from now on. It's like it's gone. Line 4 has an atomic sentence, so there's nothing to do to the sentence on line 4. There's no more decomposing that I can do to it. And line 5 has the negation of an atomic sentence, so there's nothing to do to it. So the only 2 choices left is to work either with line 1 or line 2. And both of them we already have seen branch. And the question is, well, is doing one of them a better choice than the other? And of course, immediately one of you is going to ask me, what do you mean by better? Well, better in a truth tree is always anything that saves you work, that saves you writing down sentences, because every time you write a sentence, you run the risk of forgetting a negation symbol or somehow miscopying something. So now, if you can think ahead one move here, it really, really helps. Because if you notice this sentence here, BROC, if you can imagine what it's going to do when it decomposes, and by that I don't necessarily mean that you picture it in your head. You can do it in rough work on the side here, right? If I have BROC and I dispatch that, it's going to branch. It's going to give me neg B on the left and C on the right. But if that's how it dispatches, by basically putting this branch right here, then that's immediately going to lead to a closed branch when I have the C and the neg C. So being able to anticipate that really takes your truth tree work to the next level, and it can save you a lot of work and help you avoid errors. So this strategy we call decompose to close, right? You choose to decompose the sentence that's going to lead to a closed branch. Now, in this particular problem, it doesn't matter which one you choose because they both lead to a closed branch. But in other problems, that won't be the case. So in this particular problem, if I choose this one instead, I also can immediately close a branch. I write down neg A and B as my line 6 coming from line 1. And this one closes because I have A and neg A. But I wanted to show you how to reason through that because that won't always be the case. You might have a sentence like BROC and the other one doesn't lead to a closed branch. Okay, in this case it did. And so you can finish out this tree very easily. You just branch this one out. That's going to be line 7. You write neg B on the left and C on the right. And that comes from line 2. And that closes and that closes, right? This branch here with the neg B closes because I've got B right above it. This branch closes because as I read up this branch, I go C, B, neg C. So this path is requiring that in order to make the 3 sentences at the top of the tree true, I make A true, C false, B true, and C true. And I can't do that. I can't make C both true and false. So that closes. So the set is inconsistent. Let's do a couple of more quick ones to see some of the rules that we've already explored in action. So this is going to be our number 2 example. It's a very, very simple set, neg A or B, and then A and B. And we want to know, are these 2 consistent? Well, again, I start sort of near the middle of the page and leave lots of space in case there's branching. And I stack the members of the set. And then I stop, I admire my awesome, beautiful, neat and tidy work. And I ask myself for each sentence, does it stack or does it branch? And that's not guesswork because the rule that you use to dispatch a sentence is unique because it's tied directly to the main logical connective of that sentence If it's a binary connective, if the main logical connective it's a negation, then it's uniquely chosen by the combination of the leading negation and whatever kind of sentence you are negating. So there should never be any doubt in your mind as to what rule you're going to use on a sentence. There's absolutely no choice. So for example, for line 1, if you're going to dispatch it, you're going to use the rule for the negated disjunction. Notice how I'm saying that. This part says negated, because I'm negating it, and the rest is the word for this sentence in the parentheses, negated disjunction. And that we know from the previous video, dispatches like this. So that one's going to be a stacking branch that we're going to apply to line 1. And line 2 also gives us a stack because a simple and is decomposes with a stacking rule. So this is a really, really simple truth tree. We could write A and B, and it doesn't matter which one we did first. Oops, sorry, those check marks are in completely the wrong place. Sorry, I meant to put them here. Those come from line 2. And then I can do lines 5 and 6, and I write neg A, and then I write neg B. And the importance of doing this example is that I want to show you that you must complete the application of the rule before you stop. So I check off the sentence on line 1. I write down the results of applying the rule. I write down that it came from that line. And now I stop and I ask, does the branch close? And it does close because I have here neg A and A. And so that's a closed branch. So the only thing is just make sure you're careful not to stop once you have the neg A and the A because you're in the middle of applying a rule. So always apply the rule fully, and then you can close the branch. Okay, example number 3. And there's going to be one more after this one, just in case you're curious. So example number 3 looks like this. Again, these are, the sets are not very complicated, and that's very deliberate because, again, I want you to look for patterns. I'm going to stack the two sentences, negation of A or B, and then to negation of A arrow B. And before we go any further, I want you to stop for a second and think about, will this tree close? And every single one of you out there should know the answer to that question. Without doing any work at all, without imagining how the tree is going to develop, you should be getting to the point where you can look at those two sentences and say, those two sentences cannot both be true. How can I be so confident that you can identify that? Because the sentence on line 1 is logically equivalent to A arrow B. And so if I stack A arrow B on top of its negation, it better happen that the tree closes, right? Because definitely those two sentences cannot be true. There is no truth value assignment on which those two sentences are true. So again, remembering those logical equivalences that we've been working with, which by the way are really good to summarize in one place for yourself if you haven't already done that, can be really useful. Now to get back to the task on the truth tree, the rest unfolds fairly easily because line 1 branches. And again, gradually over the next few days, you want to commit the rules to memory. But if you haven't got them memorized yet, the negation of P arrow Q stacks P on top of neg Q. So that's a stacking rule. So we're going to do that one first. Lines 3 and 4 are A, neg B, and those come from line 2. And then line 5, I branch, check that off, neg A on the left, B on the right, and of course both of those close as we expected. That came from line 1, so the set is inconsistent. All right, let's do one more. I want to show you a slightly more complicated example. And by complicated here, I mean something fairly specific. I mean that the sentences that we're going to be dealing with have a few more pieces in them. Basically, this first sentence is going to be A or neg B arrow C, and the next sentence is the negation of A arrow C. We want to know, is this set consistent? The first one is A or neg B arrow C, and the second one is the negation of A then C. We just did a negated conditional, so we know that this is going to stack. And hopefully you remember that the conditional is logically equivalent to a special kind of OR, and so the first one is going to branch. If you don't remember, the rule looks like this. I say a special kind of OR because you negate the antecedent. Okay, so the first one branches, the second one stacks, so it makes sense to do the second one first, because the fundamental heuristic that you always want to use to save yourself writing things down and therefore minimize errors is stacks before branches. So now A, neg C, and both of those came from line 2, which I check off, and always remember to check off your lines. And now we have to deal with line number 1. And the only subtlety, it's not very subtle at all, but the only place where I sometimes see students find truth trees more challenging than they really need to be is identifying the pieces, right? This entire sentence is going to play the role of script P. And this one here is going to play the role of script Q. And then I just copy the pattern, right? So I branch and I copy the pattern. I write the negation of script P. Script P is A or neg B. And then on the other side of the branch, I write the script Q, which in this case is C. So that's all you're doing is just matching patterns, right? Now I stop I've just decomposed something. I'm going to check it off, make sure I have all my notation in place. And now is when I stop and evaluate, do any of my branches close? The branch on the right has C appearing on it and the sentence not C, so that one closes. The branch on the left has A and neg C, and then the sentence that still needs to be dispatched. Since there's no conflict between A and neg C, I have to continue working and dispatch this sentence down here. This is a negated disjunction. So let me remind you of that rule. The negation of a disjunction stacks neg P, neg Q. And at first, it's really worthwhile to take your time and go slowly. This A is my script P, and the entire neg B is my script Q. So I'm going to stack two negations, right? The negation of the script P, that's going to give me neg A, and then the negation of the script Q, that's going to give me neg, and then whatever the script Q is. The script Q is neg B, so I write down neg B. And I have to write it that way. Okay? So now I pause for a minute here, and I make sure I have all my notation properly written out. So those came from line 5. And I check to see if my branch closes. Now, strictly speaking, neg B could be dispatched, and I can do that, but I don't need to because the branch already closes as I have neg A here, and then going up the branch, I have A. So this branch closes here like that, and we say that the set is inconsistent. Great. I hope you enjoyed the video.